Hello everyone, let's get started here. Welcome back to ECE100. Today we're going to talk about class 19, which is basically transistors and motors. So remember we a few class back we talked about diode, right? Diode is the very simple first semiconductor device. It has two terminals. If you supply voltage from positive to negative, your diode starts conducting. And the next device in the semiconductor industry is transistor. So transistor is a semiconductor device. It has three terminals. When you have three terminals, that two terminals used for the make conduction, and third one is kind of a control. And also, semiconductor basically in active device. What is active device? What is passive device? Like for passive device example, we have resistor, capacitor, inductor. Those are all passive device. Passive device does not need a power supply for itself to operate. Like resistor, capacitor, inductor, they don't need a power supply for themselves. But the transistor in active device, it needs a power supply by itself. It's gonna be very evident in the next slide why I'm saying that this transistor needs a power supply for itself to work, and that makes it active device. It actively needs a power supply for itself. So it has three terminals, as I said. One terminal particularly is called gate. That's a control terminal that controls the current flow through the device. So we're gonna get to that in next slide. So again, transistor has three different terminals. One is gate. So that gate will control the power conduction from here to here. So the current conduction from this terminal to this terminal over here would be controlled by the gate. If you close the gate, you make a direct conduction from this terminal that terminal, so current can go through it and motor will start spinning with the 12 volts. And if you come over here, this gate is the one here. Then for this particular transistor, this is drain, this is source. So current can go from drain to source if you close the gate. So to close the gate, you need some kind of power supply to do that. That's why it makes it active device. So actively you need to supply a voltage to the gate to close it, then you can make the conduction. So here's the thing. So different transistor would need different kind of voltage supply or current supply to close the gate. For this particular transistor over here, we need 5 volts. You can see here, we need 5 volts to the gate. If we supply 5 volts to the gate would be closed. That means we'll make a conduction from drain to source. So then your motor will have a current through it from 12 volts to ground. So your motor gonna start spinning. Now, if you supply 0 volts to the gate now, so gate would be open now, so there is no current. So the current is 0. So that means your motor gonna stop. So you're controlling the motor by controlling a supply to the gate to open it or close it. That's how you use transistor to control any device you want. So again, they actively need a supply at the gate to make this device work. That's why it's called active device. There are different variation of transistor. Some transistor needs 5 volts to close the gate. Some transistor needs a negative voltage to close the gate. So I'm not going to get to that. Is more into your ECE310. That course will talk more about this. So sometimes you need positive voltage, sometimes negative voltage to close the gate, depends on the semiconductor construction of the transistor. And there are different transistors out there. There are bipolar, CMOS, MOSFET. There are all different kinds of transistor, but all of them have the three terminals, and all of them can be controlled by a supply electrical signal. So what is the limitation of transistor? Each transistor has their own limitation. How much current they carry, how much voltage they can handle. Those are all the limitations. We need to know a data sheet to know that. Typically, gate current is very small. So nobody wants to carry current to the gate because that is not required for transistor operation. This also only required to control the transistor. So typically, it's nanoamps of current goes to the gate. Ideally, it should be 0. And drain to source, there's the main current going through the device to do some work. That current depend on the transistor. It can go from 1 amp to 20 amp to even 500 amps of current it can carry. For a particular, let's say IRF, one of the common transistor we use, IRF 640, can carry 5 amp current. So that means if you need any device that needs less than 5 amps, you can be controlled by this particular IRF 640 transistor. So ideally, there should not be any voltage drop between drain to source, but typically there's some little voltage drop between drain to source. One is conducting is typically less than 1 volts. Sometimes have typically like 0.2 or 0.3 volts drop between drain to source. Then come to the motors. If you look at the motor here, motor has, for this particular example here, we have 2 magnets. So the electric and the wire inside the loop wire inside the magnetic field. So there's a magnetic field going from north to south here. This is a magnetic field, and there's a current carrying conductor inside the magnetic field. So current carrying conductor inside the magnetic field produces torque. When you have a torque, you have rotation. That's how your motor rotates when you supply the current through the source and the brush. All right. So current carrying conductor inside a magnetic field produce torque. That torque give you rotation. That's how motor works. And we're showing only one coil here. In practice, we have hundreds of thousands of coil inside the motors. If you open the motors, you can see that there are like hundreds of thousands of coils in the motor. So you can represent this coil by using a circuit element that we discussed in last class. Any coil could be represented by an inductor. So that coil over here is basically inductor. And we represent that with symbol L, right? So, or that's inductor right here. So the coil inside the motor could be represented, the pure coil could be represented by inductor. So if you want to draw a DC motor passive circuit elements, in the DC motor have a coil, and also it has a conductor. Conductor always has a little bit of resistance. So you can represent your motor by 2 circuit elements, a coil, right, and also a little bit of resistance. So this is the motor, could be represented by L and R. All right. So that is your circuit representation of the motor. All right, I think that's all for today. We will see you for the next class. We're getting to the end of this course, and we have one more lecture, then we have projects.